fascinating introduction of mine, and it is a good fortune to deliver or give talk in this precious FDP. Today I shall start. Now let me present.
If
Okay.
your bandwidth
now
permits, will you please put camera on?
Yes, I am just switching on my camera. Okay, probably this is. No, actually, I just opened Teams. So let me just share it here. Okay. Thank you very much, sir, for such fascinating introduction. Now the topic is integrating salient sensors in Raspberry Pi and networking with them. So myself, Dr. Devobroto Biswas, and I am an assistant professor of Department of Physics, Bankura University, West Bengal. So first of all, let me introduce. I think you know probably what is single board computers are. So here I outline just different single board computers like Raspberry Pi, Orange Pi, Banana Pi, Asus Thinkerboard, etc. All are of credit card size, and it is of great advantage. So here we shall use the Raspberry Pi, which is this one. And this is the Raspberry Pi latest model, Raspberry Pi 4. It is very nice, and you can choose a wide range of RAM. It has 2 GB, 4 GB, or 8 GB RAM, and very fast processor, and more powerful. It is getting more and more powerful USB 3, some inbuilt Wi-Fi, inbuilt Bluetooth, and here you can see there is micro HDMI ports, and there is 2 micro HDMI ports, so you can switch to 2 monitors simultaneously, and there is a USB Type C power supply. You can just power it through USB Type C. There are many more things, and this one is of importance. This is called GPIO. GPIO means general purpose input output. So here are 40 pins in this model, and each pins have its own advantage, and we will come to discuss the advantages of these pins. We can program the Pi and interface external hardwares or any other controlling systems, sensors through these GPIO pins and control them as required. So how does the Raspberry Pi computer looks? This is the latest model. This one, the middle portion is the full computer, full CPU. We can take it in your pocket and go to anywhere and connect it to some keyboard and mouse and screens or projectors. You can get a very nice computer in your pocket. Actually, there was a deficiency of computers, and I used to bring the Raspberry Pi in my pocket in my college and connect it to the projector, and then make the student learn of some computer programmings. So this is very efficient one. And now let me start with the sensor, which is the main topic of this session. What is the sensor? You know all what is a sensor. A sensor is a device, module, machine, or subsystem whose purpose is to detect events or changes in its environment and send the information to other electronics, frequently a computer processors. There are some pictures of sensors in the below portion of this slide, and you can know that what is sensor. But apart from that, these are artificial sensors. What is the best sensor till The best sensor is the awe of the nature. The best sensor is the sensor of living creatures. Example, the smell sensor of dog. It is very much efficient. the skin sensor of human. The human skin is a O, because it separates your internal body parts from the external environment, with which contains many more gases, and you can sense through your skin the pressure, temperature, all to the minute accuracy. So these are the most or the best sensors in nature you can get. So we are just mimicking nature, and we are trying to build or trying to follow the nature by our own way. Now, first of all, I shall come to the physical examples of sensor. It is first one is not a type of sensor, as you can say, but it is a display. That is important one. That is OLED display. That is organic light emitting diode display. That has a different size, but here I shall use a display that is 128 into 64 bit, 64 pixel. So this is the display. You can see here are 4 pins. One is positive, one is ground, and one is SCL, and other is SDA. SCL means serial clock, and SDA means serial data. So here we will connect this this output device, or in the sense display, to the Raspberry Pi and program the Raspberry Pi in Python for just displaying what we intend in this display. Before that, just go to the GPIO of the Raspberry Pi, that is general purpose input output. You can see in a Raspberry Pi a series of pins in the right hand side of model 4 or other models. So these are the GPIO pins, and this is the detailed layout we shall use in this session about these GPIO pins to control the sensors and program the sensors. So this is the GPIO of a Raspberry Pi. And to enable the display, that is this display OLED display, you have to do some things. That is, you have to first configure the Raspberry Pi a little bit. For that, you have to open a terminal and just type sudo raspi config, and that will open a window like this. And you have to go to the 5th option, interfacing options, and you have to accept it and then finish it. Then it will interface I2C display modules. Now you have to install some required modules and some required drivers. So these are the options. You can get it from internet also. So you have to install Python dev, Python SMBus, I2C tools, Python PIL, Python PIP, Python setup tools, etc. These are required to drive the display externally. So after the installation, you can detect it by this comment, I2C detect -y1. Then you can get a thing like this in your terminal, and you can see this 3C, that is the display is detected. And now you can install the Python library for OLED, and for these are the comments. You can collect it from internet also, and the required package is obtained from Adafruit Python SSD 1306. This is SSD 1306 type of display. So we just need to sudo python setup.py install to install this. After installation, we can just connect the display to Raspberry Pi like this. We shall connect the +5 volt to this. This actually connected is 3.3, but we will use the 5 volt terminal that is in the behind part of this. And this is the ground, and this is SD. This is SDA, and this is SCL. These two are SDC and SCL. You can see from here, SDA and SCL, these 3 and 5 terminals. So we have connected this to that. Now we have to do some Python programming for connecting this. To do so, we have just connected it and written a program. That is, we have to import some module. So from OLED.device, we have imported SSD 1306 and SH 1106, and OLED.render import canvas, and from PIL import image form. After that, we have to tell the program about the fonts. The font is image font dot load default, and would have to set the device to SSH1106 port. These are the common programs, and you have to put it in your program. And to draw something, you have to do this with canvas bracketed device as draw. Then you can give the commands to draw anything or put your text. So in this program, I have written the program for drawing a line. So this is for drawing a line. These are the coordinates. This is the starting point, that is 00, and this is the end point, that is 127 and 63, and fill, that will be filled. So this is the program where I have written it for the OLED display to draw a diagonal line in the program. Let me show you a little bit. For this, I am coming. Okay, you can just, I am just coming to this part is, I think this part is OLED display. I have connected it to the Raspberry Pi, and according to that connection, this one is GPIO, as you can see, GPIO, and this is connected to OLED display. Now I shall just run the program. The program is on my desktop, and through Raspberry Pi I cannot show that program because Raspberry Pi, I have just only 1 GB module. So I am you just follow the screen. I am just giving it to here. Now going. Okay, let me enter the thing. Okay, just OLED, and now I am just giving the command python OLED, that is OLED line.py. And if I run this, you just notice the device part. So I am just running it, and you can see a diagonal line is drawn. I have just run that program in my Raspberry Pi. So you can see, if I want to draw more line, then I have to just change the program a little bit, which I will show you. But before that, you see the demo. I want to draw many lines from a point, like some ray of light, and I am just running it, and you can see there are many lines here. So let me come to that point. So I am just coming to this. For that, you have to do some programming. That is, this one is a single line. You can see, let me increase the font size, make it 16 or more, 18 say. So this is the program you just see in the presentation. And for the many lines program, you have to include that. That is, I am giving a for loop, and in the range 0 to 70, or that is, it will draw the line several times, and under the for loop, I am drawing the line with the last position changing with the for or the I. So this draws the line as you saw here. So these are the basic line drawing. Apart from that, I am coming to the texting. So these portion are same. These portion are almost same. Here the new one is this line, font 1 and font 2. You can use several font. Here I have used Arial.ttf font type, and the size is 18. So font 2, I have given name it font 2, and given the command that image font dot true type, to Arial TTF 18. I shall use font 2 here. You can use font 1 on any or any other font. So with Canvas device as draw, I am writing the draw text here. I am just writing draw text. This is the first position from where it will draw to 2. This is the XY coordinate, and first one is my name, and this is font type. This is totally filled, and this is I am drawing a line, a horizontal line from 0 to 30 and 127 to 30. That is in the middle of the screen, and this is filled, and draw text 2 to 35, and this is my title. That is the font. Now let me show you what happens when I run this in the Raspberry Pi. You can see there is another screen. I am running Raspberry Pi from here, but I am not showing, I cannot show you that as it has some speed limits. So here you can see the line is drawn. Now I am just changing the code, the last code, and running it to, you can see, just I am running it, and you can see here I have printed my name with the horizontal line which you wanted. So this is the basic thing where you can integrate or run the OLED display. That is very efficient, very necessary to see any sensor output or any other thing without any need of any large screen. This can be used for your Raspberry Pi or Arduino or any other controlling thing, and you can program it through your Raspberry Pi or Arduino. So this is the way for printing and for interfacing the OLED display. Now this is the portion of display, and second one I shall come for the sensor part. For the sensor part I am coming here. Okay, so this is the OLED display part, and writing my program which I showed you, that this is the text writing in my OLED display. Now we come to the humidity and temperature sensor. It is easily available and it is called the DHT11 temperature and humidity sensor. The sensor looks like this. The left portion, it has 3 pins, one positive, one ground, and one output. And it is connected to the Raspberry Pi through this. We shall clear it through the program, and it will, the output portion will connect to the GPIO port of the Raspberry Pi. So after connecting this, I am going to the programming part. The programming part is like this. This is the coding for humidity sensor. You can see, let me open the program from gedit text editor. This is temperature and humidity. The basic program of it is just these some lines. Okay, import Adafruit DHT, you can write this, but I shall show you the OLED program, that is integration with OLED. So you can see that this portion is for OLED display, and this portion is its fonts for OLED, and this portion is for humidity sensor. So form, temp, humidity, import, start, that is import all. This portion will have to be installed in your computer, and you can get it from DHT, from GitHub or any other websites. Just type module for temperature and humidity sensor, and you can just follow the instructions to install those in your computer. Now let me come to this while true, that is it will run all time, and I am just assigning humi and temp to variables to get temp hum bracket. So this is the part of this module, temp humidity. If you type get temp hum with some open braces, then you can get the humidity first and then temperature, and we are storing these to humidity variable, humi, and temp variable. Now I am just switching on the OLED display, and OLED display is switched with canvas device as draw. Now I am just checking if HUMI is not none, that is there is a data in HUMI and temp is not none, that is there is a data in temp, then I am just printing temp of this degree Celsius and humidity. This is the format, data format, percentage. Now dot format temp and HUMI. This is the standard Python code for printing something. And now this portion is for drawing to the OLED display, which will show the temperature. Here I draw the text temp is equal to, I am returning the temp to string and adding it and just printing it, then giving a horizontal line here, and then again a text that is HUMI, and that is string. The HUMI is converted to string and added to that HUMI string and printed. And there is an else command print failed to retrieve data from sensor. If there is no data, then it will go to else, and temperature failed or humidity failed, it will show. Now let me run this program. I have the similar program on my Raspberry Pi, which I am just running here. You will see just output of that in the OLED display, and I am trying to show you in the computer camera. Now let me show. Okay, so this is a little bit of disturbing because I don't have camera and I could not collect it in this meantime in the lockdown. So I think this, now I am opening it. I am just going to that folder in the Raspberry Pi, cd double dot, now cd temperature and humidity, and I am just running that program which I showed you just a moment before. Now Python temperature humidity OLED.py. Now I am just running, and you see, okay, that temperature is 29 degrees Celsius and humidity is 95%. And this one is the temperature sensor here. Let me show you through a pointer or a screwdriver. That will be better rather than use my fingers. And this one is the DHT11 temperature and humidity sensor that is connected to the Raspberry Pi, and it is showing the temperature here. The temperature is more or less constant. It will fluctuate if the temperature changes. It is showing 29 degrees Celsius and humidity is 95%. So it is much more humid here. You can see if you change the situation, or if you bring the sensor elsewhere, then the data may change. So this is the content. You can see here, I am just showing you in the computer, maybe it is visible. So this is the terminal. Here you can show the data are showing here, the temperature and humidity, similar things are showing, but we are using the OLED display for better understanding and for ease of the sensor. So this is the temperature and humidity sensor. You can connect it through Raspberry Pi and run it through Raspberry Pi. So this is of a great advantage, and you can have the program. I have done it here. Now, even if the temperature and humidity sensor is over, now let me switch on to another sensor that is called infrared sensor. You can connect it to your Raspberry Pi model, and then you can control it through some remote control, as you may see, like this one, some remote control. You can just press any key and you can see the change here. I have just included the program for sensing the remote infrared, and I shall show you how the data changes. and if you just, this is the basic thing, and if you want to integrate it with another circuits or another relay channels, then you can also connect the relays, so that you can just press your what is called a remote control, and you can control any light, fan, switch, or anything from the remote place. Okay, now let me show the program first. So this one is the infrared sensor. This looks like this, and you have to connect. It has 3 ports. One is positive, one is ground, and one is GPIO port, through which the data will be fed to the computer. And this one is the program. This one is the program. Obviously, it is integrated for the OLED display also. So here you can see that I am coming to that program, and let me explain it a little bit, which will, so there is IR sensor OLED. Okay, that is, this portion is for OLED and this portion is for OLED, and you have to import just RPi GPIO as GPIO. So I am importing the module RPi.GPIO and naming it as GPIO. Now I am including the IR pin 13. That is, let me come here. The page number is 17, and this one, I think, this one 17 GPIO. This means physically 11 number of pin. GPIO 17 pin, that is sorry, here 13, I have used 13. Where is 13? Okay, GPIO, let me check where is 13. Check from here. GPIO 13. Okay, GPIO 13 means this one. So here I have included the 13 and count to 0, and this is also for the OLED display. Now I have written some sub programs here. First one is setup. I am just setting up the GPIO. This is the standard code for GPIO board. GPIO.setMode, GPIO.board, and GPIO.setup, that is IR pin, that is pin number is given here, and GPIO.in, pull up down is equal to GPIO PUD up. These are the mandatory field you will require here for every program. Now I am just counting it, that def CNT and giving EV none, and to writing this program for just printing how much time it senses the infrared from the remote control. So this portion is for countdown, and this portion is for loop. GPIO add event detect IR pin, GPIO.falling.callback is equal to CNT, and while true, then I will pass, and the last one is destroy. If I want to just clean up, then GPIO cleanup. Now this is the main program. If name is equal to main, this is the standard program procedure in Python, then I am just calling setup. The GPIO or Raspberry Pi is set up for running the program, and then I am using try and except. After try, I am using just loop. You can see if I call loop, then this portion is called, and in the loop I have called CNT, that is this sub program. So you can get the printing or any other things you have given in the CNT, and except if there is keyboard interrupt, then it will destroy, that is clear the GPIO scheme, GPIO cleanup. So this one is the full program for the IR sensor and integrated it to the OLED display. Now let me run this program and show you what happens when I run it in the Raspberry Pi. So in this thing I have connected 17, go to 17. Yes, obviously I have connected this to Raspberry Pi like this, you can get, and I have written the program here, and let me show you the thing. Yes, this one. So you can see this one is the infrared detector. Here is the infrared detector module, and it is some mounted on some PCB, printed circuit board, and I have kept it in the, where is my pointer? I have kept it in the board and connected it to Raspberry Pi through these wires. Now let me run and see what happens. I am just showing you. You can see that temperature is this. Now I am just running cd ir. I have written it in ir folder. Now Python. What the name I have used, I have forgotten. IR sensor. Okay, IR sensor. IR sensor OLED.py. Now I am just running it, see what happens. This I just, oh sorry, Python, sorry, Python. Okay, now it is running, but the previous data is showing. I have not initiated anything. Now I am just pressing the remote control. Here you can see I am just pressing it here, and see the OLED's display. I have just pressed, and it is showing count 1, count 2, that is count 2. Now again if I press, then it is showing count 4. Actually in a single press, the infrared light here switches for 2 times, and it senses it twice and counts its toe. That is 6, that is 8, and you can just press and the number will increase. The number will increase more and more. You can see it here, though the visibility is not good for front camera of my laptop. So you can see 99 and 100, 101. So these are the infrared sensor. You can act it with infrared sensors, which are very important thing for automation or any other things. So this one is the infrared sensor for your Raspberry Pi. So I have shown you the connection of OLED display and DHT module for temperature and humidity, and also I have shown the infrared connection, infrared sensor, and to connect it, to program it. Now I am coming to the other sensor that is a very good and very necessary sensor, you can say, that is called avoid sensor. It senses something which just gives you some obstacles in front of your device or any other thing. You can just switch, you can just set it to the back of your car, and if you park it to any parking lot, then it will sound whether you select the distance, so there will not be any damage to your car, or many other things you can do with this avoid sensor. The avoid sensor looks like this. This is an infrared signal sender, and this is the receiver. And if you apply some avoid or some hindrance in front of this, then that will be reflected back, and it will sense, and it will process, and it will send the data to your controlling device. That may be Raspberry Pi, that may be Arduino, and according to that signal you can stop your engine, or you can do many thing or any other thing, whatever you want to do. So this one is the avoid sensor, and if you connect it to your device, you have to just input the 5-volt and ground here, 5-volt and ground, and you have to connect the digital output to some GPIO port of your Raspberry Pi. You can get detailed layout of your GPIO from internet or any other sources. So this is the connection here, and let me show you first once. Let me show you first. Okay, this one is the avoid sensor. You can see this one is the light emitting diode for infrared, and this is the receiver. And if you put some hindrance like this here, it will sense that hindrance and show the signal to your desired OLED display. Now let me show you how to program it. To program it, I have this program. I am going to explain all parts here. So I am just opening it. This is avoid sensor and avoid.py. This portion is for our OLED, and this portion is for our GPIO calling, and this is obstacles pin, and I am selecting the 36 pin, that is GPIO pin of that GPIO series, and I am just giving the name it the obstacle pin, and this portion is for OLED. Now again I am just setting up with def setup, that was just like previous one. And again I am just doing a loop while true. If 0 is equal to GPIO input obstacle pin, print barrier is detected, this will be printed in your computer screen terminal. And now I am feeding this to the OLED display with canvas device as draw. I am just saying that the status is obstacle. If there is some obstacle, there is obstacle, and else if there is no obstacle, then I am printing in my terminal no barrier, and I am printing with canvas, that is in my OLED, that is status clear, there is no obstacle, and I am just destroying it with destroy command. Now again I am giving the main function here. The main function is given by the name main, and I am calling the setup first. It will call this module, and then I am using again try and except. Try, just call the loop here, and then accept keyboard interrupt and destroy. If I press Ctrl C, then it will be destroyed and GPIO will be cleared. Now let me run this program in my Raspberry Pi and show you the thing here. This one is the avoid. Okay, I think it is visible. Okay, I am just running it. Okay, close the previous program and going to that folder, avoid, and python avoid.py. Now let us check. This is showing the counter, that is infrared counter, that is of previous. Now I am just, you can see that there is stat is CLR, it is showing there is clear. Now if I put some hindrance in front of that, I am putting my mobile phone in front of this. Now you can see I am bringing it, and it is showing that obstacle, there is obstacle. I am removing it, that is clear. I am just coming it, and it is obstacle. Again removing it, again coming it. Just put your finger here. There is obstacle, obviously. Removing it, clear. Obstacle, clear. Obstacle, clear. You can integrate many more things here to have other things done here with this avoid sensor. So this was all for this session. I have shown you 3 sensors and a screen connecting device, the OLED screen, the humidity and DHT sensor, and another one is infrared sensor, and the last one is avoid sensor. You can use many more sensors. I have, but I did not program it for today's purpose, because all are almost similar. You can get, as you can see here, there is a box, you can buy it. This is a box 37 in 1 sensor kit for Arduino. This is this may be for Arduino and Raspberry Pi. These are sensors here. You can connect all the sensors for integrating it in your Raspberry Pi or in your Arduino device. I have used the Arduino. Okay, so 3 sensors are done and 1 display is done. Now it's time for some question answer session. So I would request Dr. Bose for taking the advantage here. That.
Can you hear me? Hello? Hello, Debu. Can you
Yes,
hear
sir.
me?
Yes, sir.
Okay, so you're finished.
Yes, sir. I can hear. Yes,
So
I am finished. I have shown the three sensors.
okay, fine. First of all, thank you very much, Deobrata, for your nice presentation and the work you have done on the background, because it's very difficult, sitting in the home without getting the support from laboratory. What we did when we were discussing, Deobrata told me that if you can send me the items or the sensors. So what we did that we could send some sensors to his residence so that he can start working. But unfortunately, I could not send him a faster one, a better model of Raspberry Pi, so that earlier we planned that everything would be shown through the Raspberry Pi itself. But we could not. Anyway, thank you very much for your nice presentation. And there are a few questions we would take up. And in our laboratory also, Deobrata is instrumental to start our work, because our students started working with the help of him. So let me take the questions or the comments what has been already put into the QA box. First one is from Rakesh Jain from Shovit University. Okay, Dr. Jain, thank you very much for your comment. He has commented that, sir, I would like to get your video lecture due to programming, if possible. A very good description of sensor. Thank you very much. And I convey this to Deobrata also. We are recording, and only we have finished on Saturday. After that, on Sunday, I will take the, we have to edit some, because it's a live program, sometimes some extra videos are there, so we have to clip and edit the videos, and after that we will upload it, and definitely in the Google Drive, we will share both the presentations and the videos. We will do that, and thank you for your appreciation. Second is from Dr. Somanath Jalal. Very, very nice presentation goes to Debu. New things to me, and it is nicely presented. One question, can we get more precision in the temperature or humidity data? He's telling the time in double precision or eighth decimal place. It's a question from Mr. Jalal to Deobrata. Deobrata, please. The question is,
Yes, sir.
please.
Yes, sir. I understand. Dr. Jalal wants more precision, but this is a low-cost sensor. This is hardly cost 100 rupees. So you can get only 1 decimal of precision here. If you want to get more precise data, you have to go for some upper version of this. But for general purpose, in our homework or our laboratory works, this may be employed. I have made a digital clock with Arduino Nano, and I have used this DHT, and it shows very good humidity and temperature data there also. So the precision can be obtained, maybe doubled, but in this device it is not possible because it is a low cost device. To Dr. Bose.
Okay, thank you. Still now, no more question. Mr. Rajesh Jain has thanked you. Okay, any more question? Anybody, please? Any more question? Let us wait for a few minutes. If somebody has
Okay,
a
sir.
question and he or she throws it to you, definitely I will take up. But only 2 questions till now. Okay. One more question from Khushbu Sharma, Dr. Khushbu Sharma. Her question is it possible to use with solar power the same concept?
Okay, about what concept you can, okay, you can integrate the solar power through some power device and some regulating modules to your Raspberry Pi or any other device. You can do that. You just have to use some solar panel and just stabilize that portion and feed it to your device. So you can use the solar power on the same concept. To Dr. Bush.
Okay. Thank you, Devrata. So I think there is no more question. But before we end, just I want to show you, oh, there is something else. Okay, Tata Khushbu has thanked you. So these are the modules, what I was talking about, that we came down into this size of modules. This is a design by us, and we have developed it. So what we are planning, or what we are working, our students are working, that mm, uh, how to use this type of sensors, uh, basically for location enabled system development, for maybe for agriculture. We have worked some. If time permits, someday I will, maybe tomorrow, or if I get on the last day, we will show some examples that we have developed some systems for basically agriculture, because in our country it needs a lot of effort, agriculture, and also on of such small, very low-cost modules with other controlling systems for natural resource monitoring, basically water quality monitoring or water level monitoring. We are working on this one. It is a very new field to us. So anybody interested to work with us, it will be our privilege. And sorry, the power is gone. It would be our privilege, and I think many other persons are there who have got much more experience than us in this type of work. So we can start working. So our number is our mobile number is, another question is there. It's from Dr. Javi Gaitonde. Can we detect visible and ultraviolet light, to Debu?
Yes, we can detect the visible and ultraviolet lights, and for that we have to use some detectors that will detect the visible and ultraviolet light. You have to use the different spectrum, and you have if there is no such thing, you have to design such sensors that will detect separately visible and ultraviolet lights. Dr. Bose.
Okay. So another question is there, or okay. So that is a question from Dr. Abhishek De. It was very nice presentation, sir, and I want to know basically how to connect barcode scanner with Arduino.
Okay, that is you have to just connect any barcode. You have to just first collect the device or the sensor that sends the laser light to barcodes and receive the reflected one that may be obtained from the market or any online shopping. And then you have to just program like I have shown you according to your requirement. The barcode is nothing but the interference pattern or something like that. You have to retrieve data from that. You can get some programs inbuilt that is given in GitHub or any other sites, or you can do yourself. So this is answer. I think this answers your question.
Okay. So well, yeah, if there is no more question, we can close the session. It's already 5 o'clock. We are running. There is one more question. Okay, it's a thanks from Abhishek there. Thank you very much to Debu. It goes to Debu. And so let us wrap it up today. Before we wrap up, once again, we thank Dr. Devrata Biswas for his nice presentation and the hard work he has done for this presentation. Thank you very much. And Before we close today, 2 or 3 announcements. First, number one, please do not forget to register for tomorrow's event. Once again, maybe after half an hour or so, I will send you the link. Once again, the very same link, still I will send you so that you can fill it up for tomorrow and day after tomorrow if you like. This is number one. Number two is if already I mentioned, if you already one of the participants, she has sent her willingness to present one to present her performance in tomorrow's cultural program. If anybody else is interested, all of you are very welcome to present, and we will be happy. Today late evening, along with your link, I will send you the invitation and the details of the cultural program. But still, it's open. Anybody wants to join, please join in. And the last one, once again, thank you all the participants for your patience, for remaining with us. There were again and again some small technical glitches. We tried to come over them, and ultimately we came over with the support from you. And have a nice time after this, and see you tomorrow at 10:20. Okay, so bye-bye. Have a nice time. Thank you very much.